Welcome, my student. Our lesson today is talking about matrices. Introduction. Definition. A matrix is a set or group of numbers arranged in square or rectangular array enclosed by two brackets. Example. The first matrix in order 3 by 3. It means 3 rows and 3 columns. Row in the horizontal line, but column in the vertically line. This matrix in order through 3 rows and 3 columns. Let's go to the second example. This matrix in order 1 by 2. It means one row consists from one row and 2 columns. Matrices introduction. Properties. A specified number of rows and specified number of columns. Two numbers, row x column, describe the dimension of size of the matrices. Matrices. This matrix A11, it's represented by the first row and the second and the first column. A12 represented by the first row and the second column. Up to Aij, I represent the first row, will J represent the column. A21 represent the second row and the first column. A22 the second row and the second column. You have to start from row and column. Column matrix, or we have many types of matrices. The first one, column matrix or vector. The number of rows may be any integer, but the number of columns is always 1. The number of columns, 1 column. If the matrix contains from 1 column and any number of rows, it's called the column matrix. Another type of matrices, row matrix or vectors. A row matrix consists from one row and any number of columns. That's the row matrix because it consists from one row and any number of columns. And this is another matrix, row matrix, because consists from one row and 1, 2, 3, 4 columns. Type of matrices, regular matrix. Regular matrix contains more than one elements, and number of rows is not equal to number of elements. A number of columns. A number of rows doesn't equal the number of columns. This is regular matrix, number of rows, 2 rows and 1, 2, 3, 4, 5 columns. Number of rows doesn't equal the number of columns. Another type of matrices, square matrix. A square matrix, the number of rows equal the number of columns. This matrix in order 2 by 2, but this matrix in order 3 by 3. It's a square matrix. Another types of matrices, diagonal matrix. Diagonal matrix is a square matrix. All the elements are 0 except main diagonal. Main diagonal 1, 2, 1, 1, 2, 1. The square matrix with all the elements are zeros except those one of main diagonals. This is also diagonal matrix. all the elements are 0 except the main diagonal. The main diagonal consists from 3, 3, 5, 9. Types of matrices. Unit matrix. Unit matrix, the sample of unit matrix like that. That is the unit matrix or identity matrix. Diagonal matrix with one of the main diagonals. Main diagonals consists from 1 and all the elements zeros. That's the name as a unit or identity matrix. Now the yellow matrix. All elements in the matrix are zeros. All the elements are zeros. It's called zero matrix. Operation of matrices. Equality of matrices. We say all the two matrices are equals if and only if each element from the first matrix equals the corresponding elements from the second matrix. And the order of matrix equal the same order of the second matrix. In this case, we call that two matrices are equal. Therefore, their sides or dimensions are equal as well. Operation on matrices. The first operation, commutative property, commutative law. If we have two matrices A and B, and we add A plus B, or we add start from B plus A, it gives me the same result. Therefore, a commutative property satisfied in matrices. Associative property. Associative law, if we have three matrices A, B, and C, if we add A to the B and C, associative property, give me the same result if we add A plus B from the beginning and add C. Give me the same result if we add A plus B plus C. Look at this example. To add these matrices, A 2 by 3 and B 2 by 3. The result matrix C equals 2 by 3. Add the first A11, the first element, adding to the corresponding element of another matrix. Add 7 to 1, the result 8. 3 plus 5, the result 8. Negative 1 plus 6, the result is 5. Let's go to add the second row. 2 plus negative 4 equals negative 2. Negative 5 plus negative 2 equals negative 7. 6 plus 3 equals 9. Associative property satisfied in the matrices. This property, if we have any matrix add to the zero matrix or add zero matrix to the same matrix, the result is the same matrix. The second property, if we add any matrix to the additive inverse, the result is zero matrix. Multiplication of matrices. The product of two matrices is another matrix. Two matrices A and B must be conformable for the multiplication to be possible. It means the number of columns of A must equal to the number of rows of B. Let's go to this example. If we have matrix A and matrix B, to multiply matrix A in order 1 by 3, matrix B in order 3, 1, the result matrix in order 1 by 1. We have checked the column of the first matrix equal the row of the second matrix. The result equal the row of the first matrix, the column of the second matrix. If we have two matrices B and E, matrix B in order 2 by 1, matrix E in order 4 by 2, not possible because the column of the first matrix doesn't equal the row of the second matrix. The second one, if we have matrix E and matrix B, matrix E in order 6 by 2, matrix B in order 6, 3, it's impossible to do this operation because the 2 doesn't equal 6. The number of column in the first matrix doesn't equal the number of row to the second matrix. But this example, if we have A and B, two matrices, the order of matrix A in order 2 by 3, matrix B in order 3 by 2, we can do this operation because the column of the first matrix equal the row of the second matrix, and the result equal 2 by 2. To do identity, in this example, I want to multiply two matrices. You have to check. From the beginning, we have to check. The first matrix in order 2 by 3. And the second matrix in order 3 by 2. The first matrix in order 2 by 3. The second matrix in order 3 by 2. I can do this operation because the column in the first matrix equal the row of the second matrix. The result is the matrix in order 2 by 2. Let's go to solve. From the beginning, we multiply the first row multiplied by the first column. Why? 1 by 4 plus 2 by 6 plus 3 by 5. Give me a 1, 1. Give me the first row and the first column in the solution. The second step, we multiply the first row by the second column. The first row by the second column. First row multiply the second column. 1 by 8 equals 1. 2 by 2 equals 4. 3 plus 3 equals 9. And adding them. Give me a 1, 2 means give me the first row, element of the first row and the second column. Now we go to the second row. Multiply the second row multiplied by the first column. 4 by 4 plus 2 by 6 plus 7 by 5. This answer gave me a 2, 1, the second row and the first column. The last one, multiply the second row by the second column. 4, the second row multiply the second column, 4 by 8 plus 2 by 2 plus 7 by 3. Give me A, 2, 2. Means the second row and the second column. This is the answer of multiplication of two matrices. Remember also, identity matrix multiply any matrix equal the same matrix. Identity matrix means the main diagonals equal 1 and all the remaining of elements equal 0. If we have multiply the first row and the first column, give me 31. The first row multiply the second column, give me 21, and so on. Note that the same matrix. Therefore, if we have any matrix multiply identity equal the same result, multiply identity by the same matrix equal the same matrix. Associative law. If we have three matrices A, B, and C, multiply A by B by C equal the same result. If we multiply A, B, the result multiply C, or multiply A by B by C. Another property, distribution property, distribution multiplied over addition. If we have A multiplied by two matrices B by C, therefore distribution multiplied over addition, AB plus AC. Question. If we multiply AB doesn't equal BA, it's not conformable. If AB equals 0, A multiply B equals 0, neither A nor B necessarily equals 0. If we have multiplied matrix T and matrix S, multiply T by S, give me this matrix. And if we multiply S by T, give me another solution. Doesn't equal. It's not conformable. Therefore, AB matrix doesn't equal BA matrix. Let's go to this example. If we have matrix A in order 2 by 2, then prove that A power 2 minus 2A minus 3I equal 0. A power 2, A by A, matrix A equals A by A. Negative 1, 2, 0, 3 by negative 1, 2, 0, 3. To multiply the first row by the first column. To do this operation, multiply the first row by the first column. Give me 1. The first row multiply the second column. Negative 1 by 2, 2 by 3, give me 4. The second row multiply by the first column. 0 by negative 1 by 0 plus 3 by 0 equals 0. The second row multiply the second column. 0 by 2 equals 0. 3 by 3 equals 9. Minus 2A. Minus 2 multiply matrix E. Multiply 2 by each element in matrix E. Negative 2, 4, 0 and 6 minus 3i identity matrix 1 0 0 1 multiply 3 give me 3 0 0 3. If we add the operation addition, give me 0 0 matrix. Therefore the left hand side equal the right hand side. That's the solution of this example, equal 0. Transpose of a matrix. If we have any matrix in order 2 by 3, we can transpose it to the matrix 3 by 2. Convert the first row by the first column and the second row to the second column. If we have matrix A in order 2 by 3, to convert to A transpose, give me matrix in order 3 by 2. 2, 4, 7, the first row, convert to the 2, 4, 7, the first column. And the second row, convert to the second column. It's transpose matrix. The matrix, the basic matrix in order 2 by 3, and the transpose in order 3 by 2. Properties of transpose matrices. If we have two matrices A and B, adding two matrices and transpose the addition of two matrices equal transpose the first matrix plus transpose the second matrix. And if we multiply AB matrix and get the transpose of them equals transpose the second matrix from the beginning and the first matrix. If we have any constant, k it's a constant number, multiplied in any matrix, we get transpose. Transpose للماتريكس والconstant doesn't transpose. A transpose, all transpose, give me the same matrix. Let's go to proof. If we have two matrices A and B, adding the sum of two matrices and give the transpose. A plus B give me 8, 8, 5, negative 2, negative 7, 9. And if we go to the get transpose, convert the first row to the first column and the second row to the second column. A transpose, B transpose, adding between A transpose plus B transpose give me the same result. Let's check. If we have two matrices A and B, multiply and get the transpose, give me B transpose multiplied A transpose. That's the matrix A and that's the matrix B. Multiply two matrices, give me the column matrix 2, 8. If we transpose, give me the row matrix 2 and 8. B transpose, transpose the first the matrix B and transpose the matrix A and multiplied, give the same matrix 2 and 8. The row matrix 2 and 8 is equal. Symmetric matrix. امتى اقول ان ال two matrices are symmetric؟ if A equal A transpose. If any matrix equal transpose the same matrix, it's symmetric matrix. Like that, if we have matrix A, B, D, A, B, B, D. Transpose الماتريكس المين diagonals A و D and this element equal this element. Skew symmetric matrix. A is called skew symmetric matrix if and only if any matrix equal additive inverse to the transpose the same matrix. Let's go to this example. If we have matrix A in order 3 by 3 and A transpose additive inverse لل A transpose, it's necessary the main diagonals equal 0 and this element is additive inverse to this element. That's the main diagonal. And this element additive inverse to this element or vice versa. And this element additive inverse to this element. Additive inverse. Therefore, it's called skew symmetric matrix. Example, if we have matrix A like that is symmetric matrix, then find the value of X and Y. Let's go to solve this example. That's the main diagonal. And in this case, 2x equals -4 because it's symmetric matrix. 2x equals -4. Solve the first equation from the first degree one variable, divided both sides by 2, give me x equals -2. That's the value of x. X 6 is equal to x plus 2y because it's symmetric matrix. X plus 2y equals 6. Replace x and put -2 instead of it, plus 2y equals 6. Solve equation from the first degree one variable, 2y equals 8. Divided both sides by 2, give me y equals 4. And let's solve to this example. Since the matrix is a skew symmetric matrix, therefore negative 2z equals -6. Divided both sides by -2, therefore z equals 3. -3x equals z plus 3. -3x equals 3 plus 3 equals 6. Divided both sides by -3, give me x equals -2. The last equation, 3y minus x equals -7. 3y minus 2 equals -7. Change the sign of 7 to -7 because it's skew symmetric matrix, means additive inverse. 3y equals -9. Divided both sides by 3, give me y equals -3. Y equal -3. Okay. Determinant of the matrix. If we have any matrix, we can find the determinant of any matrix. Example 1. If we have matrix in order 2 by 2, to do the determinant, start from the main diagonal, A11 by A22, minus A12 by A21. If we have matrix A, 3, 1, 1, 2, to get the determinant, 3 by 2, start from the main diagonal, minus 1 by 1, equals 6 minus 1, the result is 5. Then the determinant of this matrix equals 5. Equals 5. If we have a matrix in order 3 by 3, to do this solution, أول حاجة من حقي أختار الفيرست رو أو السكند رو أو الثيرد رو، or الفيرست كولوم أو السكند كولوم or الثيرد كولوم. طيب say إن أنا هبدأ بالفيرست رو. remove A اللي هي ال1 اللي هي A11 هشيلها، وريموف الفيرست رو والفيرست كولوم الريليتد ليها. دلوقتي هتبقى عندي الماتريكس 2 3 0 1. طيب بس في حاجة هنعمل كده زي علامة X، كل الاليمنتس اللي علامة الإكس دي هتاخد the same sign، بس اللي مش على علامة الإكس هياخد opposite sign. يعني دي هتبقى نيجاتيف، طبعا الزيرو neither نيجاتيف نور بوزيتيف، الثري هتبقى نيجاتيف، الزيرو نيجاتيف، طبعا لو أي رقم غير الزيرو. وهبدأ إن أنا أعمل الأوبريشن. أول حاجة أنا خدت ال1 هيبقى ب1 تايم 2 باي 1 minus negative 3 by 0 plus هاخد الزيرو، انا ماشيه اول رو، انا اخترت اول رو، يبقى طالما اخترت الرو دوت يبقى هشيل الرو مع الكولوم، الرو مع الكولوم الريليتد للزيرو. تمام، نشيل بس ده، شلت الرو والكولوم الريليتد لنفس الزيرو. هيبقى عندي 0 باي 1 تالت حاجة اخترتها اللي هي ال1، بقية الرو اللي انا بادية بيه يبقى remove الكولوم والرو الريليتد ليهم، هتبقى 1 وهكتب الماتريكس in order 2 by 2 هتبقى 0 و2 ونيجاتيف 1 و0، وبعدين 2 by 1 minus 3 by 0 يبقى هتديني 2. طبعا ده كله بزيرو عشان زيرو في أي حاجة بزيرو، بلس 0 minus 2. The result equals 4. يبقى تاني أنا دلوقتي من حقي إن أنا أختار أي رو أو أي كولومز. مثلا إحنا اخترنا الفيرست رو مع العلم بإن اللي على علامة الإكس دي بياخد نفس الساين، اللي مش على علامة الإكس بياخد opposite sign. طبعا الزيرو مش فارق لأن الزيرو neither negative nor positive. بدأت أنا اخترت الفيرست رو ده، يبقى 1 أهي 1، وبعدين شلت الرو مع الكولوم. نوضحها، اخترت ال1 فشلت الرو مع الكولوم، فضل لي ده، فضل لي الماتريكس دي 2 3 1 0. عملت المين دايجونال 2 باي 1 ماينس 0 ماينس هاخد الزيرو، ناخد الزيرو هاخد الزيرو بالنيجاتيف طبعا مش فارقه، وبعدين شلت الرو مع الكولوم الريليتد للزيرو، فضل لي الماتريكس دي 0 3 نيجاتيف 1 1. بدأت بالمين دايجونال 0 باي 1 ماينس نيجاتيف 3 باي نيجاتيف 1. طبعا ده كله بزيرو مش فارق معايا. آخر حاجة أخدت ال1، هشيل الرو والكولوم الريليتد ليها، فضلت لي الماتريكس بالمنظر ده 0 باي 0 ماينس 2 باي نيجاتيف 1. نيجاتيف بقت بوزيتيف، يعني اداني 2. في الآخر الأنسر طلع ب4. وكان من حقي ان انا اختار الرو ده او الرو ده او الكولوم بس اتبع نفس الرولز بتاعتي. اكزامبل مهم جدا، ازاي اجيب الاريا بتاعت التراينجل عن طريق الماتريكس. You can use the determinant. عن طريق الديترمينانت you can use the determinant to find the area of triangle. We have triangle الvertices the first vertex A و B, the second vertex C و D, and the third vertex E و F. To find the area of triangle نفس الإكزامبل هنكتب الديترمينانت half the first projection 1 2 4. first projection للإكس axis لل3 points respectively, and the second projection لل3 points لل3 vertices respectively 0 2 3 0 2 3, and put 1 1 1 and do the determinant to get the area of triangle. The area of triangles equals half. Please try to solve this example. You can scan the QR and solve it. Thank you. Thank you, my student.